massive asteroid the size of Manhattan is hurtling toward Earth at 45,000 miles per hour. In just seconds, it will trigger the most catastrophic event in our planet's history. But before that moment of destruction, Earth was a completely alien world, one where flowers were a brand new invention, where Antarctica was a tropical paradise, and where creatures so bizarre they'd make Hollywood monsters look tame ruled supreme. Today, we're traveling back to witness the final days of the most successful ecosystem our planet has ever known. What you're about to discover will completely shatter everything you thought you know about prehistoric life. Welcome to Weird Histories. Hit that subscribe button and let me know in the comments what historical topic you'd love us to explore next. 66 million years ago, our planet was running a fever that would kill most life today. Global temperatures soared 15 degrees Fahrenheit higher than modern levels, creating a greenhouse world so extreme that palm trees grew within 500 miles of the North Pole. The very concept of ice caps didn't exist. From pole to pole, Earth was a sweltering, humid paradise that would feel more like stepping into a tropical greenhouse than the world we know. This wasn't just warmer weather. This was a completely different climate system. Atmospheric carbon dioxide levels reached nearly 2,000 parts per million, almost 6 times higher than today's already elevated levels. The atmosphere itself was thicker, more oppressive, creating a pressure cooker effect that trapped heat like a planetary oven. Rain didn't fall in gentle showers, but in torrential tropical downpours that could last for days. But here's where it gets truly bizarre. The poles weren't frozen wastelands, but lush, temperate regions teeming with life. Antarctica, that frozen continent we know today, was covered in dense forests of ferns, conifers, and the newly evolved flowering plants. Crocodiles basked on beaches where massive ice sheets now dominate. The Arctic Ocean was a warm, tropical sea, where marine reptiles the size of school buses hunted among coral reefs. This extreme warmth created weather patterns that would seem alien to us. Without ice caps to regulate ocean currents, the seas circulated in massive, slow-moving gyres that distributed tropical temperatures across the entire planet. Storm systems were more intense but also more predictable, following patterns that had remained stable for millions of years. The jet streams that drive our modern weather didn't exist in the same way, replaced by gentler but more persistent wind patterns. Scientists have discovered fossilized wood from deciduous trees that lose their leaves seasonally, buried in Antarctic ice. These weren't struggling survivors, but thriving forests that experienced months of continuous daylight, followed by months of twilight, yet never dropped below freezing. It's a world where seasons existed not through temperature changes, but through light cycles, creating growing patterns we can barely comprehend today. The very shape of our continents tells a story of a world almost unrecognizable from today. North America and Europe were still connected by a massive land bridge, while a shallow tropical sea called the Western Interior Seaway split North America completely in half. This inland ocean stretched from the Gulf of Mexico to the Arctic, creating 2 separate land masses where we now have a unified continent. Standing on the western shore of this ancient sea, you would have gazed across 600 miles of warm, clear water to the eastern landmass. Marine reptiles larger than modern whales patrolled these waters, while primitive seabirds dove for fish that hadn't evolved into their modern forms. The coastlines weren't the familiar beaches we know, but alien shores lined with volcanic islands and coral reefs extending far into northern latitudes. India was still an island continent racing northward at breakneck geological speed, carrying unique ecosystems that had evolved in isolation for millions of years. When it finally crashed into Asia, it would create the Himalayas. But in the Cretaceous, it was a tropical landmass unlike anywhere else on Earth, populated by dinosaurs found nowhere else in the fossil record. Africa and South America had only recently begun their slow separation. Still close enough that similar species lived on both continents. The South Atlantic was a narrow channel, more like an expanded river than the vast ocean it would become. Australia remained locked in its southern position, covered in forests that would seem familiar to modern eyes, but populated by creatures from nightmares. The global ocean levels were so high that much of what we consider dry land today lay submerged beneath warm seas. Florida was completely underwater, as were vast portions of Europe and Asia. Mountain ranges that seem ancient to us were just beginning to form, while others that dominated the Cretaceous landscape have since eroded to nothing. This wasn't just geography. It was a completely different Earth operating under physical laws we struggled to fully understand, where the very foundations of climate and weather followed patterns that had no modern equivalent. While this greenhouse Earth might sound like a tropical paradise, it was also a planet in geological chaos that would terrify modern inhabitants. Massive volcanic systems, some larger than entire countries, regularly erupted with an intensity that makes modern volcanoes look like gentle campfires. The Deccan Traps in what would become India were spewing millions of tons of lava and poisonous gases into the atmosphere, creating acid rain that could dissolve limestone and corrode organic matter. These weren't isolated eruptions, but sustained periods of volcanic activity that lasted thousands of years. The sky often glowed red from airborne ash and sulfur compounds, while toxic gases like hydrogen sulfide created dead zones in the oceans where nothing could survive. Yet life had adapted to these extreme conditions in ways that seem impossible by today's standards. The ocean chemistry was so different it would kill most modern marine life instantly. Dissolved metals reached concentrations that would be toxic today, while oxygen levels in deeper waters dropped so low that vast underwater deserts formed where only bacteria could survive. The seas literally changed color seasonally, as different microorganisms bloomed and died in cycles driven by volcanic activity. But perhaps most shocking was the atmospheric composition itself. Not only was carbon dioxide much higher, but other gases we consider trace elements today made up significant portions of the air. Methane levels spiked regularly, as massive swamps released trapped gases, while sulfur compounds from volcanic activity created a perpetual haze that filtered sunlight into an eerie golden glow. Despite these seemingly hostile conditions, or perhaps because of them, life exploded in diversity and size that we've never seen since. The constant warmth and abundant carbon dioxide created a greenhouse effect that supercharged plant growth, supporting ecosystems so productive they could sustain creatures weighing over 100 tons. This was Earth as an alien world, beautiful, deadly, and operating under rules that would challenge every assumption we have about what makes a planet habitable. The stage was set for the most successful era in Earth's history, when giants would walk among forests so dense they blocked out the sun, and when the very definition of what it meant to be alive was about to be rewritten. The largest land animals that ever lived were walking Earth 66 million years ago, and they were so massive they challenged the very laws of physics. Argentinosaurus weighed as much as 12 African elephants combined, over 100 tons of living, breathing, plant-eating machine that could strip entire forests bare in a matter of days. Their necks stretched 60 feet into the air, allowing them to browse treetops that no modern animal could even dream of reaching. But here's what's truly mind-blowing. These weren't slow, lumbering giants struggling under their own weight. Recent fossil evidence shows they moved in coordinated herds across vast distances, following seasonal migration patterns that spanned entire continents. Their footprints, preserved in ancient mudflats, reveal a walking speed that would outpace a human jogger. We're talking about animals the size of buildings moving with the grace and coordination of modern deer herds. The engineering required for these creatures to exist seems impossible. Their hearts had to pump blood up necks longer than telephone poles, creating blood pressure that should have burst every vessel in their bodies. Yet they solved this problem millions of years before humans even existed, developing specialized blood vessels and heart chambers that functioned like biological hydraulic systems. Some species had hearts weighing over 400 pounds, larger than most entire animals alive today. Their digestive systems were factories of efficiency that put modern industrial processes to shame. A single Argentinosaurus could process over a ton of plant matter daily, using specialized gut bacteria that broke down the toughest plant fibers with chemical reactions we still don't fully understand. Their stomachs contained gastroliths rocks they deliberately swallowed to help grind food, some weighing over 50 pounds each. What's even more shocking is that these giants weren't exceptions but the rule. Dozens of different sauropod species roamed every continent, each adapted to different food sources and environments. Some had necks specialized for ground feeding, others for high browsing, and some could switch between both. They weren't just surviving in this alien world. They were the undisputed masters of it, reshaping entire landscapes with their very presence and creating ecological relationships that would never be seen again. If the plant eaters were impressive, the predators hunting them were the stuff of absolute nightmares. Tyrannosaurus rex wasn't just a big dinosaur. It was a perfectly engineered killing machine with a bite force of over 35,000 pounds per square inch. That's enough pressure to crush a modern car into scrap metal with a single chomp. Their teeth weren't just sharp, but designed like curved railroad spikes, some over 8 inches long, capable of puncturing bone and ripping through flesh with surgical precision. But T-Rex was just one member of a terrifying family of apex predators. Giganotosaurus was even larger, reaching lengths of over 50 feet and weights exceeding 8 tons. These weren't just big lizards, but sophisticated hunters with keen intelligence, forward-facing eyes for depth perception, and sensory systems that could detect prey from miles away. Their sense of smell was so acute, they could track wounded animals across vast territories, following scent trails days old. Recent discoveries have revealed that many of these predators hunted in coordinated packs, using complex strategies that would make modern wolf packs look primitive. Fossil trackways show multiple large theropods moving together, spacing themselves to surround prey in calculated ambush patterns. Some species even showed evidence of role specialization within packs. Smaller, faster individuals to chase prey toward larger, more powerful pack members positioned for the kill. The diversity of hunting strategies was staggering. Carnotaurus had forward-facing horns and was built for high-speed pursuit, reaching speeds of over 35 miles per hour, despite weighing several tons. Therizinosaurus looked like a predator, but was actually a massive plant eater, with claws longer than baseball bats, used for stripping vegetation and defending against attacks. Meanwhile, real predators like Utahraptor combined intelligence, speed, and retractable sickle claws that could disembowel prey with a single kick. Perhaps most disturbing was their apparent intelligence. Brain casts reveal complex neural structures, suggesting problem-solving abilities, long-term memory, and even possible emotional intelligence. These weren't mindless monsters, but calculated killers capable of learning, adapting, and remembering successful hunting strategies. Some species show evidence of tool use, manipulating their environment to create advantages during hunts, displaying cognitive abilities that wouldn't be matched by mammals for tens of millions of years. The most shocking discovery in paleontology has completely rewritten what we know about dinosaurs. Many of them were covered in feathers. Not just small bird-like species, but massive predators sporting elaborate plumage that would make modern peacocks jealous. Utaranus, a relative of T-Rex weighing over 3,000 pounds, was covered head to tail in primitive feathers that likely provided insulation in cooler climates and visual displays during mating season. These weren't the flight feathers we see on modern birds, but something entirely different. Proto-feathers that served multiple functions we're only beginning to understand. Some were hollow and provided insulation more effective than modern down jackets. Others were brightly colored, with fossil evidence showing iridescent blues, deep reds, and metallic greens that created visual displays more spectacular than any modern bird of paradise. The color patterns weren't random, but sophisticated communication systems. Borealopelta, a heavily armored herbivore, had countershading coloration, darker on top, lighter below, that provided camouflage despite weighing over 3,000 pounds. This suggests predation pressure so intense that even tank-like herbivores needed to hide from hunters. Some theropods had striped patterns similar to modern tigers, while others displayed bold warning colors that advertised their dangerous nature to potential threats. But the real revolution was happening in the trees and skies. Early birds like Confuciusornis had already mastered powered flight, soaring above forests on wings spanning over 3 feet. These weren't primitive gliders, but sophisticated flyers capable of aerial maneuvers that modern birds would recognize. They shared the skies with pterosaurs, but represented an entirely different evolutionary solution to the challenge of flight. Even more bizarre were the 4-winged dinosaurs like Microraptor, which had flight feathers on both their arms and legs, creating a wing configuration that has no modern equivalent. These creatures could glide between trees and perform aerial stunts that defied conventional understanding of flight mechanics. They represented evolutionary experiments in controlled flight. This feathered world was vibrant, colorful, and dynamic, in ways that make our modern ecosystems seem almost monochrome by comparison. The oceans of 66 million years ago were ruled by predators so terrifying they make modern great whites look like goldfish. Mosasaurus hoffmanni stretched over 50 feet long and weighed more than a modern sperm whale. But unlike whales, every inch was designed for killing. Their jaws could open wide enough to swallow a small car, lined with backwards curving teeth that ensured nothing escaped once caught. These were not just big lizards. They were perfectly adapted marine killing machines that had evolved from land-dwelling ancestors in less than 20 million years. What made mosasaurs truly nightmarish was their hunting strategy. Unlike modern marine predators that rely on speed or stealth, mosasaurs were ambush predators that could strike from the depths with explosive force. Fossil evidence shows bite marks on ammonite shells, spiral-shelled creatures related to modern squids, that reveal crushing forces exceeding anything in today's oceans. They didn't just bite their prey, they pulverized it. But mosasaurs weren't the only marine monsters patrolling these ancient seas. Leadsichthys was a bony fish that reached lengths of over 80 feet, making it larger than most modern whales. Unlike gentle whale sharks today, this prehistoric giant was an active predator, with jaws capable of processing massive amounts of smaller fish and marine reptiles. Schools of these giants would have created feeding frenzies that turned entire sections of ocean red with blood. Even more bizarre were the plesiosaurs, marine reptiles with necks so long they defied physics. Styxosaurus had a neck containing 76 vertebrae, stretching over 20 feet long and allowing it to strike at prey from impossible angles. These creatures moved through the water like underwater snakes, their massive flippers propelling them with surprising grace and speed. Their necks weren't just long but incredibly flexible, capable of making S-shaped curves that let them ambush fish from directions their prey couldn't see coming. The fossil record reveals that some plesiosaurs gave birth to live young in the open ocean, suggesting complex social behaviors and migration patterns. These weren't cold-blooded reptiles struggling in marine environments, but highly adapted ocean dwellers that had perfected aquatic life in ways that would never be seen again after their extinction. While massive predators ruled the seas, the skies belonged to creatures that make modern birds look like insects by comparison. Quetzalcoatlus northropii was the largest flying animal that ever lived, with a wingspan reaching 35 feet, wider than many modern aircraft. But calling it just large misses the point entirely. This wasn't a scaled-up bird, but a completely different solution to powered flight. An animal that could soar for hours without flapping its wings while scanning vast territories for food. These pterosaurs weren't struggling to stay airborne under their massive size. They were masters of their aerial domain. Fossil evidence shows they had hollow bones stronger than steel, air sacs throughout their bodies that reduced weight while maintaining strength, and wing membranes that could adjust their shape for different flight conditions. They could take off from flat ground despite wingspans larger than small airplanes, using a unique four-limbed launch that generated enough force to become airborne in seconds. But perhaps most shocking was their intelligence and social behavior. Pterosaur nesting colonies contained thousands of individuals working together in complex social hierarchies. Some species showed evidence of parental care extending for months or even years, with adults feeding and protecting young long after they could fly. Braincasts reveal neural structures suggesting problem-solving abilities and spatial intelligence rivaling modern birds. The diversity of pterosaur species was staggering. Pteranodon soared over the western interior seaway with a wingspan of 25 feet, using thermal currents to travel hundreds of miles while barely flapping. Nyctosaurus had bizarre head crests that may have supported skin membranes used for display, or even primitive sound production. Some species were covered in hair-like filaments called pycnofibers that provided insulation and possibly even primitive color patterns. These weren't just big flying reptiles, but sophisticated aerial predators with hunting strategies unknown in the modern world. Some species could dive into oceans from heights of over 100 feet, using their momentum to spear fish with surgical precision. Others were terrestrial stalkers, using their massive size to hunt small dinosaurs and early mammals on foot. They had conquered three-dimensional space in ways that wouldn't be matched until the evolution of modern birds, and even then, no bird has ever approached their maximum size or aerial capabilities. Beneath the waves, ecosystems existed that were so alien they seemed like science fiction. Ammonites, spiral-shelled cephalopods related to modern octopuses and squids, grew to sizes that boggle the mind. Parapuzosia sepenradensis had shells over 8 feet in diameter, making them larger than truck tires and weighing several hundred pounds. These weren't slow, bottom-dwelling creatures but active swimmers that could jet through the water using the same propulsion system as modern squids, just scaled up to impossible dimensions. The diversity of ammonite species was mind-boggling. Over 10,000 different types have been identified, each with unique shell patterns, hunting strategies, and ecological niches. Some had shells coiled in tight spirals for maximum swimming efficiency, while others had loose, irregular coils that may have provided specialized feeding advantages. Their shells weren't just protection, but sophisticated buoyancy control systems that allowed precise depth regulation, letting them hunt at specific ocean layers where their preferred prey congregated. But ammonites were just one part of marine ecosystems that operated on scales we can barely comprehend. Rudist bivalves, clam-like creatures, grew in massive reef systems that stretched for hundreds of miles, creating underwater cities populated by creatures that have no modern equivalents. These reefs were so large they influenced ocean currents and weather patterns, yet they were built entirely by animals that filtered microscopic plankton from the water. The ocean floor itself was covered in creatures that seem impossible. Inoceramids were giant clams that could grow over 6 feet long, filtering massive amounts of water and concentrating nutrients in ways that supported entire food webs. Some marine environments were so productive they supported predator densities that would collapse modern ecosystems. Imagine waters where every square mile contained multiple mosasaurs, plesiosaurs, and giant marine crocodiles all competing for territory. Perhaps most alien were the microscopic ecosystems that supported all this massive life. Coccolithophores, single-celled algae with intricate calcium carbonate shells, existed in such vast numbers they turned entire ocean basins white with their blooms. Their fossilized remains would eventually form chalk deposits hundreds of feet thick, representing biological productivity on a scale that modern oceans couldn't sustain for a single season. Yet these Cretaceous seas maintained such conditions for millions of years. 66 million years ago, Earth was witnessing one of the most dramatic revolutions in the history of life: the rise of flowering plants. What we take for granted today, colorful flowers, sweet fruits, and the intimate partnership between plants and animals, was a brand new experiment that was reshaping the planet in ways that seem almost magical by modern standards. Before flowering plants, Earth's landscapes were dominated by ancient gymnosperms, conifers, ferns, and cycads that reproduced through wind-blown spores and pollen. The world was green but largely colorless, a monochrome palette of browns and various shades of green stretching across every continent. Then, almost suddenly in geological terms, explosions of color began appearing as flowering plants evolved the most sophisticated reproductive strategy life had ever devised. These early flowers weren't the delicate blooms we know today, but often massive, primitive structures that could span several feet across. Some of the earliest flowering trees produced blooms larger than dinner plates, filled with potent fragrances that could be detected for miles. The chemistry involved was revolutionary. Plants were producing complex organic compounds specifically designed to manipulate animal behavior, creating scents, colors, and even psychoactive substances that would ensure their genetic success. But here's what's truly remarkable. This floral revolution wasn't happening in isolation. As flowers evolved, they were simultaneously driving the evolution of entirely new groups of insects, early mammals, and even dinosaurs. Fossil evidence shows that many plant-eating dinosaurs were developing specialized feeding adaptations, specifically for processing these new flowering plants, creating evolutionary partnerships that were reshaping entire ecosystems. The speed of this botanical revolution was unprecedented. Within just a few million years, the blink of an eye in evolutionary terms, flowering plants went from rare novelties to dominant species across most terrestrial environments. They weren't just adapting to existing ecological niches, but creating entirely new ones, establishing relationships with pollinators that would become some of the most complex biological partnerships ever documented. This wasn't just about pretty flowers. The evolution of flowering plants was fundamentally altering atmospheric chemistry, soil composition, and even global climate patterns. Their rapid growth rates and efficient nutrient cycling were pumping oxygen into the atmosphere while pulling carbon dioxide out, contributing to the lush, hyper-productive ecosystems that could support creatures weighing over 100 tons. The forests of the late Cretaceous were so alien that modern botanists struggle to imagine how they functioned. Ancient conifers that had dominated for over 100 million years still towered above the canopy, some reaching heights of over 400 feet, taller than modern redwoods, and far more massive. These were not the familiar pine trees we know today, but bizarre species with trunks over 30 feet in diameter, and branch structures that defied conventional understanding of tree architecture. Beneath these giant conifers, a completely different world was emerging. Early flowering trees were experimenting with growth patterns that would seem impossible by today's standards. Some species grew in spirals, their trunks literally corkscrewing toward the sky in helical patterns that maximize sunlight capture while minimizing competition with neighboring trees. Others developed hollow trunks that served as living apartment buildings for small dinosaurs, early mammals, and countless species of insects. The understory was populated by ferns that grew to tree-like proportions, creating layered forests with complexity that modern ecosystems can't match. Tree ferns reached heights of over 60 feet, their fronds spreading in geometric patterns that created natural cathedrals beneath the main canopy. Some of these ancient ferns had trunks covered in specialized root systems that formed living bridges between trees, creating interconnected networks that could share nutrients and water across vast areas. But perhaps most alien were the early palm trees and their relatives, which had evolved trunk structures that could bend and flex like living rubber. These weren't rigid trees, but flexible giants that could sway through 90-degree arcs without breaking, adapting to the intense storm systems of the Cretaceous climate. Some species had trunks that could actually coil and uncoil in response to weather conditions, laying flat during storms and standing erect during calm periods. The forest floor itself was carpeted with flowering plants that had evolved strategies unknown in modern ecosystems. Some species grew in perfect geometric patterns, creating natural mandalas that extended for acres. Others had developed chemical communication systems so sophisticated they could coordinate flowering across entire forests, creating synchronized blooms that would attract pollinators from hundreds of miles away. These weren't just plants growing together, but integrated biological networks that functioned more like single organisms distributed across vast territories. Not all of the plant evolution happening 66 million years ago was beautiful. Some of it was downright sinister, as flowering plants competed for pollinators and struggled to avoid being eaten by massive herbivorous dinosaurs. They evolved chemical warfare strategies that would make modern poison plants look harmless by comparison. Some species produced toxins so potent that a single leaf could kill a multi-ton dinosaur within hours. Archifructus, one of the earliest flowering plants, didn't just produce nectar to attract pollinators. It produced mild hallucinogens that would alter the behavior of visiting insects, making them more likely to visit other flowers of the same species. This was an accidental, but a sophisticated form of biological manipulation that ensured reproductive success through chemical mind control. Fossil evidence suggests that some pollinating insects became so dependent on these psychoactive rewards that they couldn't survive without them. Even more disturbing were the carnivorous plants that were evolving to supplement their nutrition by trapping and digesting small animals. Some of these prehistoric pitcher plants grew to enormous sizes, with trap structures capable of capturing and dissolving small dinosaurs, early mammals, and large insects. Fossil discoveries have revealed pitcher plants with chambers over 3 feet deep, lined with specialized cells that could produce digestive enzymes powerful enough to dissolve bone. The arms race between plants and their herbivorous predators created some of the most bizarre adaptations in evolutionary history. Some plants developed explosive seed pods that could launch projectiles with enough force to injure attacking dinosaurs. Others evolved bark that contained microscopic glass needles, making them impossible to chew without causing severe internal injuries. Certain species even developed specialized thorns that would break off and remain embedded in attackers, slowly releasing toxins over a period of weeks. Perhaps most shocking was the discovery that some plants had evolved to specifically target dinosaur physiology. Chemical compounds found in fossilized plant material show molecular structures that would have interfered with dinosaur metabolism, hormone production, and even brain function. These weren't random toxins, but precision biological weapons designed to exploit specific vulnerabilities in dinosaur biochemistry. The late Cretaceous wasn't just about giant animals. It was about an escalating biological arms race, where even the plants had become predators in their own right. The asteroid that ended the age of dinosaurs didn't just fall from space. It arrived like a bullet from hell, traveling at 45,000 miles per hour, when it slammed into what is now the Yucatan Peninsula. The impact released energy equivalent to billions of nuclear bombs detonating simultaneously, creating a crater over 100 miles wide and 12 miles deep in less than a minute. But the real horror wasn't the impact itself. It was what happened in the 24 hours that followed. Within seconds of impact, a fireball hotter than the surface of the sun expanded outward at supersonic speeds. Everything within 600 miles was instantly vaporized, not burned or destroyed, but literally converted from solid matter into superheated gas. The shockwave that followed flattened forests across entire continents, creating windstorms with velocities exceeding 1,000 miles per hour that stripped bark from trees and hurled boulders like pebbles. But the truly apocalyptic effects were just beginning. The impact launched trillions of tons of vaporized rock, water, and organic matter into the upper atmosphere, where it spread around the globe in a matter of hours. This debris cloud glowed red-hot as it re-entered the atmosphere, turning the entire sky into a radiant oven that cooked everything on the surface. Global temperatures spiked to over 300 degrees Fahrenheit, hot enough to boil water and ignite spontaneous fires across every continent simultaneously. The first creatures to die weren't killed by the impact, but by the infrared radiation from the glowing debris cloud. Any animal caught in the open during daylight hours was literally baked alive as the sky itself became a giant heating element. Fossil evidence shows that many dinosaurs died in positions suggesting they were seeking shelter, trying desperately to hide from heat that came from everywhere at once. Within 6 hours, massive earthquakes triggered by the impact were racing around the planet, collapsing cliff faces, draining lakes, and creating landslides that buried entire ecosystems under millions of tons of rock and debris. The Western Interior Seaway, that massive inland ocean that split North America, began draining as the seafloor shifted and cracked, stranding marine reptiles in rapidly evaporating pools where they suffocated in the toxic air or were buried alive in the resulting mudslides. As the initial firestorm subsided, an even more sinister killer began its work: total darkness. The massive debris cloud that had superheated the atmosphere now blocked out virtually all sunlight, plunging Earth into a nuclear winter that would last for months. Photosynthesis ground to a halt almost immediately, beginning a cascade of ecological collapse that would work its way up through every food chain on the planet. The first to die were the giants. Massive sauropods that required hundreds of pounds of vegetation daily found themselves in a world where plants were withering and dying faster than they could consume them. These creatures, which had dominated terrestrial ecosystems for over 100 million years, began starving within days. Fossil evidence shows that many died in groups, huddled together as if seeking comfort as their world literally disappeared around them. Tyrannosaurus rex and other apex predators faced a different but equally fatal challenge. As herbivorous dinosaurs died off, the food web collapsed from the bottom up. These massive predators, which required enormous amounts of meat to sustain their metabolism, found themselves in a world where their prey was becoming extinct faster than they could hunt it. Some fossil sites show evidence of cannibalism during this period, with large theropods feeding on the carcasses of their own species in desperate attempts to survive. The toxic atmosphere made breathing increasingly difficult for large animals. Acid rain, created by sulfur compounds blasted into the atmosphere by the impact, began falling within hours, poisoning water sources and creating chemical burns on exposed skin. The pH of rainwater dropped to levels comparable to battery acid, dissolving the shells of marine creatures and stripping leaves from the few plants that had initially survived the heat pulse. Even more insidious was the carbon monoxide and hydrogen sulfide that began building up in the atmosphere as organic matter decomposed faster than it could be processed by dying ecosystems. Large animals with high metabolic rates were essentially being poisoned by the air itself, slowly suffocating even when oxygen was still available. Brain scans of fossilized dinosaur skulls from this period show evidence of neurological damage consistent with chronic poisoning, suggesting that even those who survived the initial catastrophe were slowly losing their cognitive abilities as toxins accumulated in their systems. While the giants were dying, a hidden world of survivors was taking advantage of the chaos. Small mammals, which had lived in the shadows of dinosaurs for over 100 million years, suddenly found themselves inheriting a world where being small was an advantage rather than a liability. These tiny creatures, most no larger than modern rats, had evolved to be incredibly efficient at processing whatever food they could find, and their low metabolic rates meant they could survive on scraps that wouldn't sustain larger animals. The first mammals to thrive in the post-impact world weren't the cute, cuddly ancestors we might imagine, but opportunistic scavengers that fed on the countless carcasses littering the landscape. These early survivors had stomachs capable of processing rotting meat that would kill modern animals, and immune systems that could handle bacterial loads that would be lethal to larger creatures. Birds, the direct descendants of dinosaurs, became the unlikely inheritors of the aerial kingdom, while their massive pterosaur competitors crashed to Earth as the food webs collapsed. Small birds could survive on seeds, insects, and carrion. Their ability to fly allowed them to escape localized toxic zones and find food sources scattered across vast distances. Some species even seemed to thrive in the chaos, with fossil evidence showing rapid population growth during the months following the impact. Perhaps most remarkably, some dinosaur species actually survived the initial catastrophe, clinging to life in isolated pockets where conditions remained marginally habitable. Recent discoveries have revealed dinosaur fossils dating to several thousand years after the impact, suggesting that the extinction wasn't instantaneous, but a prolonged death spiral that took millennia to complete. These final dinosaur populations were dramatically smaller than their pre-impact ancestors, evolutionary dwarfs that had adapted to a world of scarcity and toxicity. The survivors weren't just tough. They were adaptable in ways that would reshape the future of life on Earth. Small mammals began diversifying at unprecedented rates, evolving into ecological niches that dinosaurs had occupied for millions of years. Within just a few million years, mammalian predators would grow to sizes rivaling the smaller dinosaurs, beginning an evolutionary arms race that would eventually produce creatures as diverse as whales, bats, and humans. The Cretaceous extinction wasn't just the end of one chapter in Earth's history. It was the violent birth of the modern world. Every mammal alive today, including ourselves, owes its existence to the catastrophic events of that single day 66 million years ago. The paradise of the giants was over, but from its ashes would rise a new kind of world where intelligence, adaptability, and social cooperation would become more important than size and strength. The age of monsters had ended, but the age of survivors had just begun. The world we've explored today, with its giant predators, flying monsters, and toxic paradises, seems like pure fantasy, but every detail is backed by solid scientific evidence carved in stone. The fossils don't lie. Earth 66 million years ago was a planet so alien, so extreme, and so magnificently dangerous that it challenges everything we think we know about what life can accomplish. These weren't just bigger versions of modern animals. The creatures of the Cretaceous had solved biological problems in ways that seem impossible by today's standards. They had evolved engineering solutions, chemical weapons, and survival strategies that push the very limits of what physics and biology allow. From sauropods that defied gravity to marine reptiles that turned oceans into hunting grounds. From flowering plants that manipulated animal behavior to pterosaurs that owned the skies. This was life operating at maximum intensity. What's perhaps most humbling is realizing that this incredible world, more diverse, more productive, and more spectacular than anything alive today, was completely erased in a single day. All those millions of years of evolution, all those perfect adaptations, all those complex ecosystems built up over geological ages, gone in 24 hours of fire and darkness. It's a sobering reminder of just how fragile even the most successful forms of life can be when faced with planetary catastrophe. Yet from that destruction came opportunity. The small, adaptable survivors that inherited the post-impact world would eventually give rise to everything we see around us today. The mammals scurrying in the shadows became elephants, whales, and eventually humans. The small dinosaurs that survived became the 10,000 species of birds that fill our skies. Even many of our modern plants trace their lineages back to the hardy survivors that weathered the apocalypse and rebuilt the world from scratch. The Cretaceous period shows us that Earth is capable of supporting life on scales and in forms that stretch the imagination. But it also reminds us that no matter how successful, how perfectly adapted, or how dominant a species becomes, the planet itself has the final word. The giants had their day in paradise, and then paradise ended. Now it's our turn to write the next chapter in Earth's incredible story. The prehistoric world we've explored today is just one of countless incredible chapters in Earth's 4.5 billion year story. From the first sparks of life in ancient oceans to the rise and fall of civilizations, our planet has witnessed events so extraordinary they make the best science fiction look ordinary by comparison. What other lost worlds would you like us to uncover? Maybe the bizarre creatures of the Cambrian explosion, when life first learned how to build shells and eyes. Or perhaps the frozen hell of Snowball Earth, when our entire planet turned into a giant ice cube. Could be the rise of the first forests that literally pulled so much carbon dioxide from the atmosphere they triggered an ice age, or the volcanic nightmare of the Great Dying that wiped out 96% of all species. History is full of these incredible stories that most people never hear about, and that's exactly what Weird Histories is here to change. Every week, we dive deep into the strangest, most shocking, and most fascinating events that have shaped our world. If you enjoyed this journey back to the Age of Giants, smash that subscribe button and ring the bell so you never miss our latest discoveries. And here's something to think about as you go about your day. Every breath you take, every step you walk, every moment you exist is only possible because of that catastrophic day 66 million years ago. Without that asteroid, you'd never have existed. Sometimes the most terrible disasters in history create the opportunities for entirely new kinds of life to flourish. Drop a comment below and let me know which prehistoric mystery you'd like us to tackle next. The past is full of secrets waiting to be uncovered, and trust me, reality is always stranger than fiction. Thanks for joining me on this incredible journey through deep time. Until next time, keep questioning, keep exploring, and remember, The most amazing stories aren't in movies or books. They're written in the rocks beneath your feet.